Hi, today we're going to look at function operations using addition and subtraction. So I have three functions, f of x, g of x, h of x. We're going to combine them in different ways. So first one, I want to combine f and g. So I'm going to look at my f problem, I'm going to look at my g problem, and I'm going to add those two groups together. So let's start. I have 5x plus the group 3x plus 1. Um, Basically, we're just going to be combining like terms here. So 5x plus 3x gives us 8x. That 1 stands alone. Bring it down. And we're done there. F plus g of x equals that. Let's try it again with subtraction. So we're taking the same two groups. This time we're going to subtract them. So we've got 5x minus the group 3x plus 1. So this first problem, the parentheses weren't really a big deal because we had a plus sign and the plus sign in the front, and it doesn't really change anything. However, now we have a minus sign. This minus sign is going to change everything because of parentheses. It's like we're going to distribute this negative. So I'm going to take care of that negative first before we combine like terms. So distribute, you get negative 3x, distribute again, you get negative 1. Let's combine 2x minus 1 and bring down our function notation, f minus g of x. Good. One last one, we've got g and h this time. So there's your two groups. We're going to add them up. 3x plus 1 plus the group x squared plus 2. Now, if you want, you can put both of these in parentheses just to show that this is the first group, that's the second group, that's fine. We have a plus sign in the middle. It's not really going to change anything for us, so we can leave it. And really, you could completely ignore those parentheses. You can get rid of them if you want. They have no effect on what we're about to do. So now it's just a matter of combining like terms and putting them in order, in descending order, highest exponent to lowest. So highest exponent, x squared, nothing combines with it, so it's all by itself. Next is 3x, good, and now we just need to combine the 1 and the 2 to give us a 3, and then bring down our function notation. G plus h of x equals this group. Now, the only other thing that we can do here is we like to find, when we're dealing with functions, figure out what the domain is. What numbers are we allowed to plug in? My domain, I can plug in a 0 here, 8 times 0 plus 1. I could plug in a 5 here, 8 times 5 is 40 plus 1. I could do negative numbers if I wanted to. I could even put decimals and fractions. What I'm trying to say is you can plug in any single number that you ever wanted into that x and nothing's going to get messed up. So we say, what numbers are we allowed to plug in, domain? All real numbers. Every number that ever existed, we can plug them in there, all those real ones. With the subtraction problem here, again, 2 times a positive, 2 times a 0, 2 times a negative, 2 times a fraction, decimal, it doesn't matter. My domain, all real numbers. I can plug anything in. And does that domain change when we have an exponent of 2? Not really. Remember, that gives us that parabola shape. And my domain, everything going left and right, all those x's. So what numbers can I plug in for there? Well, I could plug in positive, negative, 0, decimals, fractions, who cares? My domain, all real numbers. And that's finding function operations with addition and subtraction.